Right. So we hear something called criticality related to that. There is a fast breeder reactor that India is working on which is supposed to attain criticality. So frequently we hear in the news that it has not yet attained criticality. So in nuclear technology terms, what does it mean by criticality? What does the term criticality refers to nuclear technology?
Where the reactor can self-sustain.
Exactly, whether reactor can self-sustain. What do you mean by that?
Means, the fuel which you are giving, it is producing more than that and it can recycle.
So basically the idea is, if you say that a particular type of reactor is attained criticality, it is able to sustain chain reaction, meaning every neutron that is produced as part of a nuclear fission reaction is able to induce fission of more uraniums. Okay, because of that continuously heat is being released, continuously electricity is being produced. If there is an ongoing process and the sustainable nature is happening, then you call that so and so reactor has attained criticality. Okay, so we are expecting a fast breeder reactor to attain criticality, which is frequently in the news. And for next stage reactors, we don't have technology yet. We have not created technology for the next stage reactors. So tell me, now this question focuses on fast breeder reactors. Consider the following statements regarding fast breeder reactors India is developing as per the 3-stage nuclear program. These reactors generate more fuel than they consume. Is it the property of fast breeder reactor? They breed more fuel. So this is true. Then they use a strong moderator to thermalize neutrons. Do they use strong moderators? Is there a process called thermalization that takes place in these nuclear reactors? Are you aware about this? A very fundamental feature of fast breeder reactor. Okay, I'll leave it. We'll talk about it. They can use thorium-232 as fuel and make up fissile uranium. We are talking about stage 2 reactors here.
No, sir.
Two key properties. One is this. They are called breeders, meaning they breed more fuel, they generate more fuel. If you give them plutonium, stage 2, plutonium is the input and plutonium is the output. It consumes less fuel and makes more plutonium, stage 2. But the idea here is to use fast neutrons. What are fast neutrons? Neutrons that have high mobility. In PHWRs, we use what is called moderators. In first stage reactors, we use moderators. What do moderators do? They slow down neutrons. Fast breeder reactors, we don't use moderators. One of the main feature of fast breeder, fast means fast neutrons. If you are allowing neutrons to stay fast, meaning you are not moderating them. There is no concept of moderation in fast breeder reactor. A very fundamental feature of fast breeder reactor, they don't use strong moderator, they indeed use a very weak moderator, like what is called liquid sodium. This is one key property of fast breeder reactors. So this is wrong, this statement is wrong, first statement is right. So these are the things that you need to be aware about for working of nuclear reactors in the country. Then they can use thorium as fuel and make up fissile uranium. Although in stage 2, initially our focus is to create more plutonium, but eventually what we want to do? Eventually we want to introduce thorium into these reactors. And when thorium absorb these fast neutrons, they undergo a reaction, because these are called, what type of material is thorium? Is it called fissile or fertile material? Fertile. Have you heard about these terms, fissile, fertile? Is it fertile or fissile? Thorium. thorium doesn't undergo fission easily. So thorium though can be converted into uranium-233, which is fissile. This is fissile material. So meaning it can undergo fission using slow neutron. Whereas thorium is considered to be fertile material. Although it cannot undergo fission, but it can give rise to a material that can undergo fission. So it is a fertile material that can give rise to fissile material. This concept is very fundamental again in nuclear reactions. So thorium by itself cannot be used as a fuel. We have enough resources of thorium in the country, but we cannot use them as fuel. So what do you need to do? You have to introduce this fertile material into fast breeder reactors so that they can be converted into fissile material like uranium-233. We have these uranium-233, uranium-235 and plutonium-239 are the most famous fuels for reactors. Other components like uranium-238, thorium-232 are fertile. They cannot undergo fission, but they can become fissile materials. So our goal in stage 2 reactors is introduce thorium, which we have abundant supply. How much of thorium reserves we have in India? What percentage of world thorium reserves we have in India? 10%, 20, 25%, 50%, 90%. 25%, a quarter of world reserves are there in India. We have a lot of access to thorium, but thorium cannot be used as a material in nuclear reactors. So what do? They can put it through this second stage reactors, fast breeder reactors, to breed more fuel called uranium-233, and third stage reactors will use uranium-233 as a fuel. So statement 3 is right or wrong? Right. They can use thorium as fuel and make up fissile uranium. So statement 1 is right, statement 3 is right, only statement 2 is wrong. Okay, which of the statements are correct? What is the right answer to this? 1 and 3 are correct.